left off with, going over reflection, and Mr. Bonow had you guys, had a few of you come up and plot the points, but I just want to hit some more important points of reflection. So what he showed you, so this reflection right here is reflecting over the y-axis, and what you need to know about reflection is whenever you're going from an original figure to a new figure, your points have to be the same distance from that line of reflection. So if this is your line of reflection right here is the y-axis, notice that on the original figure, here's your point right here. Alright, your original point is here at 2, 2. So whenever you reflect it, you have to make sure, since this one was two units away from this line of reflection, then you have to make sure that the point of the new figure is also 2 units away from the reflection. Same goes for this one. This one was 2 units away from the reflection, the line of reflection. So this point has to be the same distance from this line of reflection, and that's how you're going to do it. So let's just say, for instance, this is your original figure right here, and I had you to reflect it over the x-axis. What would this point right here be? So this point right here is at 2, 2. So what was the new point for the new figure after reflecting it over the x-axis? What would the new one be? Yes, ma'am. It'd be 2, because this point right here is 2 units away from the x-axis. So the new one will be 2 units from the x-axis as well. And that's how reflection goes. So now I'm going to hand you guys whiteboards and thousand markers, and I want you to, we're going to go over translations and dilations, and I want you guys to follow along with me. Oh, yeah.
What you're going to want to use is the gridded side of the whiteboard.
Translation. So yesterday we said translation, was to shift the figure up, down, left, and right. So this says to shift this figure 2 units to the right. So in translation, you're going to find each point in a figure, and you're going to make sure that you translate that figure however many units it says in whichever direction. So. And I do want you guys to follow along. So go ahead and plot the points that's already on the original figure there. 0, 0, negative 2, 0, and negative 2, 2. So go ahead and plot those points for me. 0, 0, negative 2, 0, negative 2, 2.
Okay, and now.
One more. Yes, ma'am.
Is smart being covered up?
No, now,
Okay. Smart over.
It's on every way.
Okay, so shifting this figure two units to the right. So, like I said, you take each coordinate point of the figure and you're gonna shift it however many units it says in whatever direction. So in this instance, it says 2 units to the right. So we're gonna start with this top point right here, which is negative 2, 2. So you're gonna shift it 1, 2 units to the right. So there's your first point for your new figure. And then we're gonna go to this point, negative 2, 0. You're gonna shift that one 2 units to the right. Here's your new point. And then this middle point of your original figure, that's gonna move 2 units to the right, and there's your new point. And there's your new translation of your new figure. And that's how you're going to translate each time. Okay, go ahead and clear your board so we can do the next one.
I thought it goes through something where it won't. Other days.
Okay, so problem 2 is going over dilations. With dilations, what you do is for each, just like we said yesterday, dilation can either be a reduction or it can be an enlargement. Could you guys go ahead and plot this triangle? I'm sorry, it's the same triangle that you had just a second ago. 0, 0, negative 2, 0, negative 2, 2. So go ahead and draw that original figure for me. Okay, so in dilation, you're either going to enlarge the figure or you're going to reduce the figure with scale factor. And in this case, it says to make the triangle twice as big. So in this case, the scale factor is equal to 2. So with dilation, when it tells you what the scale factor is, you're gonna locate each point of the figure. So these points are 0, 0, negative 2, 0, and negative 2, 2. So once you have located each point on the figure, then you're going to multiply each coordinate by whatever the dilation is. So the dilation is 2, or the scale factor. The scale factor in this instance is 2. So you're going to multiply each one of these by 2. So when you multiply 0 times 2, the answer is going to be 0 exactly. So this point will stay the same. Negative 2 times 2 is negative 4, correct? So that point is going to be negative 4, 0. And we already said 4, exactly, positive 4. And that's how you create a dilation. Whatever the scale factor is, you multiply the coordinate points of the original figure by whatever the scale factor is. So when we come and graph it, you have 0, 0, you have negative 4, 0, and you have negative 4 and positive 4. And there's your new dilated figure. And that's how you do dilation. So we've covered reflection, translation, and dilation so far. So next, what I'm going to have you do, I want you guys to have the exact same. I want you to have the exact same original triangle, the 0, 0, negative 2, and negative 2, 2. I want you to go ahead and draw that one because I'm going to let you guys do all 3 transformations into another figure. I said, I want you guys to already have the triangle that's posted on the smart board. I want you to go ahead and have that one on your board. At 0, 0, -2, 0, and -2, 2. Okay, the first thing I want you to do to your original figure is I want you to use the scale factor of 2. That's the first thing I want you to do to the figure that you already have drawn. I want you to dilate that figure with the scale factor of 2. So go ahead and do that right now. I want you to dilate it using the scale factor of 2. You don't have to worry about the reflection part yet. Dilate your figure using a scale factor of 2. First, I don't want you to dilate. Don't worry about the rest of it. Yes. Okay, after you have dilated with the scale factor of 2, I want you to reflect that new image over the x-axis. Reflect that new image over the x-axis.
The original.
Now, with the new image that you have reflected over the x-axis, I want you to translate it with the units that's given on the board. 3 units up and 4 units to the right. Use the new figure that you just reflected over the x-axis. Translated 3 units up and 4 units to the right. Remember, you're using the new figure that you just reflected over the x-axis. Translated 3 units up and 4 units to the right.
This is your new figure, right? So now make sure to bring it up and 4 units to the right. So even if I shift them, is he gonna look different? Right, so he's probably not gonna think right. Somewhere. When you move something, it doesn't make it look different. Good job. Good job. If you're moving something, then it changes the size of See, that was a lot. This is your green right here. All right, guys. Remember when we did already 2 transformations? We went from
Is it not?
This was for our transformations, and then we flipped it over the axis. And it looked like this. This is your new figure. So what can your figure not look like if it's gonna, when it translates, does it change the way it looks, or does it just move? Just move. So would an answer like this be correct for your new figure?
No. No.
Right? Because it was like this before, so it can't have changed. Yeah. I just need to erase this guy.
Yeah, I got it. Like, no.
Okay, raise your hand if you're finished with this one. Let me do that. I think everybody's done.
Okay, so Mr. Bo now, he already showed
Yes.
you what the dilated figure should have looked, what your dilated figure should have looked like. This one should be your dilated figure because we did, we multiplied it by 2, so the points. These were the points of your original figure. So when I told you to use the scale factor of 2, what you should have did, you should have multiplied each of these points and each of the coordinate points by 2. So when you multiply 2 times the 0, 0, you're still going to get 0, 0. When you multiply negative 2, 0 by 2, your new point should have been negative 4, 0. And when you multiply 2 by negative 2, 2, you'll get negative 4, 4. And that's how you got your dilated figure. Okay, when I ask you to reflect it over the x-axis, your new figure that you dilated, the top point up here was negative 4, 4. It was 4 units away from the x-axis in which I asked you to reflect it over. So that means your new figure, it should also be 4 units away from the x-axis. So that's where your new point is right there. The 0, 0 stays the same. And then that point stays the same. And that point stays the same as well because it's already on the x-axis. So when we do translation, you take each point of the figure that you had down here and you translate it exactly how I told you to. So this one says 3 units up and 4 units to the right. So you're just going to start with this point. So here's your new point for that one. This point. There's a new point right there. And there is your translation of the figure after you reflected it over the x-axis. And I do see the see. Everybody pretty much got that one. So great job, guys. Okay, next. I am. Let's see. Okay, could I get you two to move to the table? Okay, so next, at your tables that you're at right now, you guys are going to be a team, and what we're going to do, we're going to play Jeopardy. So, in your teams, you guys make sure that y'all work together in Jeopardy. You know, talk to each other before you give an answer.
Hey, bring your hand if you're excited about Jeopardy. Everybody ever play Jeopardy? All right. Hey. 1, 2, 3 eyes.
Okay, guys. Before we get started with Jeopardy, could you guys stack up your boards, your erasers, and your markers so we can go by and pick them up? If you haven't already erased your board, go ahead.
All right. 2 people in your groups. You're going to be very dependent upon your players, your other teammates, because if you have problems or have questions, you're going to need to work with your teammates to find the answer to that problem. So we have group 1, 2, 3, 4. Yeah, 4 groups. That's 5. Okay. Right, but I'm going to need everyone to list their names in their groups. So this is group 1. This is group 2. This is group 3. Y'all are group 3. Okay, focus y'all. Y'all are group 4. And you all are group 5. Okay? So everybody knows their groups. What I need you to do is I need you to have everyone in your group write their name under their group number. So if you all want to put it, you all are group 1, so write your name under group 1. And since we've been talking about transformations, Jeopardy is going to be over here. All right, so your categories are what type of transformation, which is most likely going to go over what kind of transformation is being shown. Solving for dilation, solving for translation, solving for reflection, and then more than one includes more than one kind of transformation. So you're going to be maybe seeing a reflection and dilation, or dilation and a translation.
What type of transformation? Like you have things like the reflection or something like that?
Like I'm going to show a transformation and then you have to tell me it's a dilation or it's a reflection. So let's start with group 1. Oh, does she get around everyone?
It's back there.
Okay. So let's start off again. We'll start off with group 1. Which number do you want group 1? What number? 10 points? All right. Group 1. Right. You think it's a reflection? Why do you think it's a reflection? You have to explain why it's a reflection. They say it's a reflection because the mountain up here is reflected over the water. Does everyone see that? Right, he is right. 10 points to group 1. All right, group 2. What category do you want?
What type of translation? 20.
Solve for translation?
What type of translation?
For 20?
And I will keep
All right, group 2, you got a dilemma. It looks like this is a little harder than the last one. So,
I think
all right, everybody calm down, everybody calm down. I know you all know it, I'm going to see if they know it. So what do you think it is? They say it's a translation. A translation is where a figure moves.
Yeah, it is the same,
Right.
right?
So if this is the original, and does it look any bigger?
No.
Right, so it's the same size,
It was moved down.
but it was, you can see it was moved. So it's moved or it's translated. So that is 20 points to group 2. All right, for 50?
Yeah.
Oh, we'll take there. Okay. So for reflection. All right, this time, since you called it, you get to come up. Oh, you want to answer it?
Yeah.
All right. You think you got this? All right. All right. And reflect over the x-axis. So where is the x-axis? Does it go from left to right or? All right, what do you all think? Does this look like it? All right. And you wait for 50 points, so that is 50 points to group 3. Oh, yeah.
No, you can't do it at all. I have to, not here.
All right, group 4, it's your turn. What do you want?
We'll do solving for translation.
50? Got some risk takers here. All right, what is the definition of translation?
definition of a translation, like,
You don't need a specific definition, like you need what you think a translation means.
take a figure and slide it somewhere, or just like,
Just slide it.
just like, move it over.
Sliding, like if I slide, I'm just moving left and right.
Oh, like slide different directions.
Like your kind of directions.
Up, down, and right.
See what it says. Translation shift a figure up, down, and or left and right. So that is 50 points. Group 4. All right, group 5. You're going to go for a 50. What do y'all want to do? Wait, y'all.
Hey, Cameron. No, I'm not. Then when I become famous, like, oh, that was good in my video.
The sections that you haven't touched are solved for dilation, more than one. That's pretty much it. So you want to try something different?
Keep watching it over and
Solve for translation.
over.
All right, guys, you got one more section. You got 2 more. All right, pick one.
5, 4, 3, 2, 1.
What number? How many? 40? Solve for reflection, 40? Translation or reflection? All right, 40. All right. So which one of your group do you want to go over there and solve for the reflection? All right. Yep.
For the axis is reflecting over height, and that way you know it's going to be in the
And so reflect over the y-axis. Where is the y-axis?
Yeah, color, I was like, draw a line down, and you know that, that's got to be, that line has to be in between your pictures.
Great job.
Good job. Everyone see that?
Oh, that.
That answer is correct. So that is 40 points. All right. I know that seems short, but we are kind of in for time. But so we're gonna take. We know you've all learned a lot today. Y'all done the reflections over the x and y. You've done translations. You've done everything. So I think you all ready to take the big challenge. I know y'all don't like the sound of this, but we're gonna take a quiz. But it's not. Don't worry. It's not as hard as you think.
This quiz should be done independently, so there should be no talking as the quiz is being passed out, as you're working on it, eyes on your own paper.
But you can move back to the other desk.
Alright guys, the quiz is passed out, so there should be no voices. The quiz should be done independently.
What is it?
Okay. Quiz is getting out. Anybody not get a quiz? When anyone is done, just raise your hand and me or Miss Holt will come to you. Pick up the quiz, okay? what did we learn for the past 2 days? Anybody? Transformations. If you were to say what transformation is, what would you say a transformation is? Way of making something different, right? Anybody ever seen the movie Transformers? I know it's kind of a corny subject, but like the transformer is, in its way, is something that changes into another thing. You can either. So, what kind of transformations do we have? Right, so there's translation, right? Reflection. What's the other one? Dilation. So what does translation do? It slides left to right and it moves. Okay. How about a reflection? Axes. So a reflection is where the figure flips over the axis. And then, all right, so we have that. So what is a dilation? How does it make it bigger or smaller? Can a scale factor be a decimal?
Yes.
All right, so what happens when you have a scale factor that's a decimal?
You round it.
Does the figure get smaller or bigger? All right. And
Hold on a decimal, it could be like 1.5. It depends. If you look back up there, what happens if it's smaller, if it's less than 1, what's going to happen? If it's less than 1, what happens to your figure? Does it get bigger or smaller? Smaller. So if it's 1.5, that's bigger than 1. That's got your whole number to it. So what's going to happen? Bigger. So you can have the decimal, but you have to make sure to look at it if it's smaller than 1 or if it's larger than 1. Okay.
all right. And here's the one question I had during the lesson. Can you use more than one translation? Does order matter though?
No.
All right, for those who say no, why no? What happens? Okay, so how about this? If I was to say this figure up here, if I was to translate it, then reflect it, then dilate it, does the order matter on that one?
Yes, it does.
So in some conditions, you're saying the order matters. Explain.
Well, if you do a, say, it says reflective dilate or dilate to effect. But if you say reflective dilate, and you don't do it in that order, you will dilate it first, it won't be reflected right.
So if you make it if you make it big and then you reflect it, it won't be really rich.
Reflection. It wasn't going to be able to reflection if you dilate first, if the order is just like that.
So if you dilate first before the reflection, it won't really be an accurate reflection
Yeah.
of the clear. Do you understand what she's saying? She's right. If you dilate it and then reflect it, it won't be like the small image it used to be. All right, so hopefully you all learned a lot today about transformations and everything. And I'm really thankful that you all were so great today. I'll hand you over back to Ms. Hank.